Hello to everyone watching and listening us on the planet Earth. It's 8:30 a.m. in the morning, and we are broadcasting from Tallinn, Estonia. I'm Nadrhan Yusupov, and this is an episode of Leaders and Engineers. Today, our guest is an automation engineer focusing at automating final assembly in the electronics industry, in the 5G industry. He is the Masters of Mechanical Engineering, and he is a Doctor in Intelligent Automation. Formerly, he is a footballer and performance athlete with over 20 years of experience in the sport, and became the world champion with the Estonian team in the Icosathlon event in 2015. Now he's living in Dallas and working in the Ericsson United States Smart Factory. Please meet Dr. Spartak Ljasenko.
Good morning, everyone.
How should I call you? Dr. Ljasenko or Spartak?
Spartak is good enough, I think, for the context of an English-speaking audience.
All right.
That should fit.
Agreed. Well, then, Spartak, how do you do?
Good, thank you. I'm in a working trip in Estonia right now. Good to visit my homeland for a change.
Did you manage to accomplish what you planned in your trip, or still many things left unchecked?
I think so. It's been very fruitful. We're working on a global project right now, and I'm one of the technical drivers for it. The project is much bigger than it seemed initially when I was first introduced to it, but it's good. It's got big intentions, got a lot of influence, lots of responsibility for me, but I can see it being very beneficial for Ericsson in general, if we can make it happen.
Good to hear that, and I know that you are it was not easy to agree on the time. You're in a very tight time frame here in Tallinn before you go back to Dallas, and thanks a lot for finding the time.
No worries.
And I have prepared lots of questions, but I hope that will not be too intimidating. But the concept is now we'll switch to the mode that it's kind of like a job interview. And it's a job interview into the leadership position in the company. And the company, it's an engineering company. It doesn't exist, this company, but we'll pretend. And after that, I will ask you to give feedback. I will say, okay, we switch back to the normal mode. This is not the job conversation mode. And ask to give your feedback. How did you feel about those questions, and
sure.
how it's related to your job interview? Are you ready?
Yes, although immediately I feel unprepared because I've not studied the company. I don't know what it expects from engineers.
But this is part of fun.
Okay, sure. Let's make it happen. I'm applying somewhere, like a machine gunner. Some people just apply everywhere and hope they get a job somewhere.
Yeah. So now we're changing the heads.
Sure.
We're applying to the leadership position.
Sure.
I'm in, so to say, in HR of that company. All right. So now starting a job interview mode. Hello, Spartak. Thank you for applying for a leadership position in our engineering department. And our company is producing Swiss Army shovels. And you will be leading a team of engineers developing this product. You will see this on your screens. I will show just to Spartak how it looks like.
Oh, that's impressive.
Yeah, so you can switch basically to different tools, and you can dig and do many cool different stuff.
Fantastic, yeah, that's a very handy tool.
I'm glad you like it. That's the spirit. So why have you decided to apply for this position?
Well, in general, Swiss companies are known for ingenuity and for very high value added processes and high value products. And this is a very good example of Swiss engineering. So obviously I want to aim for the highest possible accolades in my profession. So here I am.
By the way, this didn't mean to be a Swiss company. This is this Swiss Army knife.
Okay,
it's like analogy to.
Yes, although I would argue that you wouldn't be allowed to call your product the Swiss Army shovel unless it's a Swiss company. I think the Swiss are very pragmatic on this side of things. But okay, yeah, let's proceed as if it's not Swiss. But, we're talking about a multifunctional shovel then, and yeah, sure, it's something portable, something that can be used for many purposes.
Yeah, exactly, and we are very excited in our company about our product. We are still launching to this market. We don't know how customers will react, but hopefully you will, if we're successful here, then probably you will lead us to this development of success. But I see you know already something about our company. This is good preparation.
Thank you.
All right, so on your LinkedIn page, as a position you put, let's do it right the first time, every time. So what inspired you to put that statement?
The inspiration comes from repeatedly failing in the past, simply by applying the trial and error methodology. And experience just shows that if you can fail your idea early enough, it's going to cost you the least. So by the time you've built something, by the time you present something to your customer, you better have it right. There's no second time to make a first impression. There's no second time to go back to your vendors and ask them, can you make us the same components again, please, but different ones a little bit, and we're just not going to pay you for them. Yeah. So by the time you're face to face with your customer and you're delivering your deliverable, that's when it has to be right.
You're saying about the customer, but in the design process before it gets to the customer, is it okay to do this trial and error and basically iterate over different experiments?
It is.
Or still you rather theoretically calculate everything and build straight away the right from the first time?
I completely agree that it may not be possible to do it on the first iteration, get it right. But you should really aim to close all the holes.
Mm-hmm.
At the very least on paper or in your CAD model or whatever you're modeling or designing what you're doing, it has to be watertight already there. Because if you're not quite sure about your work, then once it becomes a physical reality, you know for sure there's going to be many more problems that you couldn't take into account earlier. So it's like the Olympic idea in sports. Obviously that's inspired from that as well. An athlete will never be as strong as a god, but the idea of Olympism, if you like, is to strive for the perfection. And that's where this came from, really.
That's really admirable to hear, and I think what we might refer to this as a continuous improvement.
Yeah.
But don't you think, let's say there are this concept design thinking agile, where the product is not ready, so to say, it's a draft, but you go and show to your customer. Did I understand correctly that you're saying that there is no need for that part? You just, in the beginning, you listen to the customer and you deliver final product which is like nice and perfect?
It is a very good option if you've been given free hands on what you're delivering. Unless a customer has specified what exactly they need from point A to point B, all the points. We shouldn't necessarily need that, but it's always good to get a round of feedback. And also when you do go there, then you best address what the customer has specified. On the other hand, if the customer has not specified much, they just said that we need something to do the specific task for us, so we need this function fulfilled, please do something about it. And then in the engineering team's mind, this idea might be great, and it's fantastic if we can go and present it to the customer, and then the customer can give us a feedback loop. So this definitely eliminates a lot of issues in the process, and once you do get to the actual deliverable, then you have much more certainty that you'll do it right for the first time.
So basically you say, depending on how much resources you're given, you can basically adjust how much you can iterate and show how much room you have, so to say, for mistake.
Yes, you could say so. It's dependent on the situation, obviously. On your resources, that's one of the points. But sometimes the customer is not very clear on what they wish. I'm sure both of us have experience in that thing. And it's important when you present something to the customer, here's my idea, what do you think of it? That if you get the green light for that, that's it, you're on your way to getting it right for the first time. As opposed to hiding something or not quite presenting the full thing, and then you kind of get an okay, maybe they didn't quite like it, and they got that out, but you still push forward with the idea, and that's your path to the spectacular failure.
Yeah, I definitely agree with you on that.
Mm.
And you also had experience of being a department manager here in Ericsson in Tallinn. Tell me about your experience. What was the hardest thing for you there?
The hardest thing was the ever-changing environment and the changing stances from the management side. So unless from the higher up positions I'm not getting the perfect instructions, or at least close enough to what's expected and where do we want to be in 3 years from now, and the only instruction I get is just keep things running now, and then we'll figure something out later. It's not very good for building something. Engineers, when you're leading a group of engineers, they are a very specific type of creatures. They like to build something. They're creators. And if instead of creating, you tell them just to hang in there, do something, get by somehow, just don't let things break, then it's not a very good instruction for them. I don't find that. This loses the motivation in the workers. This doesn't lead to very good results, because the obvious question is going to be, so I know where I am today, but where's my point B? Where should I be moving towards? And that was the case for us. That was a period of time in Ericsson when there was a lot of restructuring, and I was part of it. So I'm glad that's passed now. We're in a much more secure place today.
Glad to hear that. So, before you were here in Estonia, now you're in the United States. Could you please tell what motivated you to move? What was behind your decision to move to the United States?
I found maybe 4 or 5 reasons. Some of them are personal reasons, out of my interests. I don't know if these are appropriate to mention here, but for the professional reasons, key thing is that I find the automation team stronger there. So there's more space for my personal development, learn from others, and actually contribute as an equal. And also in the United States, the labor costs are higher, and the factory has somewhat more funding, which means the automation projects can go a little bit wilder than they can in here. So I found in our factory in Tallinn, we were relatively limited in terms of what we could do as engineers.
And I believe this designation from beginning that it's a smart factory probably positioned this into the place where it was by default designed that there would be kind of less restrictions on what kind of experiments can be done, less alignment with maybe other sites in Ericsson.
Less alignment, maybe. Although right now there's a strong push for standardization. The smart factory itself, well, if you ask 10 different people, you'll get 10 different answers. What is a smart factory? But in our case, what's important is that we get a lot of very high-profile customers and visitors. We get the last big visit was, I believe, in December. We had the director of AT&T, a giant telecommunications company in the US. So he visited us, and one of my projects was used to deliver him the contract where he signed it. So that was quite a fun experience. And why I'm saying this is that the factory over there is to a large extent a showcase factory. So we need to show robots, we need to show technology, we need to show that we're stepping into the future. Yeah, so we're not relying on just manual labor and various jigs. We actually get lots of data from our processes. We optimize them, and that's where we're headed at. That builds confidence in the customers.
Definitely, I would assume AT&T, they get the final product, but they came to see how it's produced, how it's made.
Yes. We have a lot of visitors from very different industries, but telecom is obviously the main one.
Great. So if you talk about yourself on a more like as a personal and professional level, how do you think your colleagues would describe you? What are top 3 characteristics they would give you?
The strong mechanics guy, the guy that talks a lot, and the guy that has terrible humor. I think these are.
You assume, or they told you directly?
The mechanics guy, that's what I hear a lot. The other 2 I assume myself, because statistics. Yeah.
I won't say that you are terrible humor. I'm always enjoying when you crack the joke, and that's always cool.
That's good to hear.
But if you talk about top 3 things that you think you need to improve, what would they be? If there are any, of course.
Oh, there's plenty. The thing is, the more you learn, the more you understand how little you know. Yeah? So if you see someone very confident who pretends they know everything, then I'm afraid that's not a very good professional. One of my big issues that I see is on the electrical side. So I'd like to be one of those Da Vinci type of engineers who know everything from every category. Having a mechanical background, I'm very happy what I can do mechanically. But once we get to the electrical side, and all these powertrains and how they function, that's definitely a weakness. Then I found that multitasking is not exactly my strength. Once my to-do list gets to more than 10, I struggle to respond to people on time. I struggle to provide the quality necessary. Personally, I don't allow myself to just quickly reply to everyone without having thought through what I'm telling them. That's not a good idea. So you might think you get your work done fast, but that'll backfire. Third one, possibly communication abilities. I have a general stance, which is my normal Spartak. But if we're talking of engineering, where you talk to your customers, you talk to your team, you talk to production, you have to understand that they have different needs. They maybe use different wording and things. They see things differently. So if I could learn to adapt to that, I talk to the production people in the production language. I talk to vendors in the vendor language. I think that would be a big bonus. This is something I'm looking to develop.
So I mean, talking not just to immediate, so to say, end user, but on the whole chain of.
Yes. So the operator in production, they don't care is this piece made of aluminium or steel, but your vendor is going to have a very important distinction between the 2. That's one little example. And if I've spoken to operators, I'm trying to talk to them in a way that, hey, how's this machine work? Does it jam or anything? Yeah. But when I talk to vendors, I can show some statistics. Look, we have this much downtime, that much downtime. If you start talking to an operator about downtime, how frequently this happens, or do you think it was connected to the network? And that's never going to happen. So you have to simplify the language at the very least with operators. They're not the PhD people usually.
They also mentioned that you would like to have cross-domain knowledge, as I understood. And what do you think of mechatronics field? Is it really preparing this kind of specialists who, like, I don't know if you came across those people? And
mechatronics, do I understand correctly, you're asking about Taltech specifically, or a general course of mechatronics?
In general, because this mechatronics is kind of become general field of engineering. So there are civil engineers, there's mechatronics engineer, electronic, mechanical engineer. Okay.
So it's electrics or electronics and mechanics. Yeah, that's what mechatronics puts together. It's one of those things like you get with a multi-eventer in athletics. So I, as a multi-eventer, I was good at lots of events, not exactly fantastic at any. So in some industries, you need that one person who who can put things together. He's not the Da Vinci, yeah. He's not Elon Musk. He's not going to build you a spaceship or anything. You need some very, very specific skill sets in the more complex industries. But as a generalist, I think that's fantastic. So you can hire one person. You don't have expectations that he's as good as a Formula One engineer in anything specific, but they can take on a wide range of tasks, and I think that mechatronics prepares you for that. That said, the university is only the beginning. Yeah? So you graduate, you get your bachelor's, your master's degree, fantastic, you have a solid base. But did you pay attention? Did you really do the coursework properly? Or did you just cram for the exams and forget everything once you're done with the exams? When learning the things, did you ever think how you can apply these things? There's so much to the foundation to start with, and that is only the foundation. Once you get to work, your work experience, the places where you work, they have a huge effect on you.
All right. Now, if you talk about motivation, you have a team of engineers, and how would you motivate your team to perform better?
Many options. We highly depend on the structure, of course. Are these engineers working together, or are they working in different segments? Like in Ericsson, we have a team of engineers. In my case, that was my team of automation engineers and equipment engineers, but they were split up into segments. So one of these barely knows what the other one's doing, so for their collaboration, little can be done. We just discuss how things go and just propose some ideas occasionally. But if we're talking about the team that we have in Dallas right now, it's very different. The way our team was built is we have a specialist for almost every field. So we have someone who's fantastic at robot programming, we have a strong mechanics guy, we have someone who understands networks to an incredible level. We have a vision specialist, we have a dispensing specialist. So we overlap each other in the same segment, and we put our strengths together into building one very good thing, as opposed to having generalists who hopefully scramble something together that works. And that's I think that's a very, very good way to run an automation team. And if you ask about motivation, then there is it. You got great teammates, you communicate a lot, you get along very well, and you're building something together. So you participate in things, you can propose to improve things, and literally we see very good results. So that's a motivation. As stated earlier, an engineer is a creator, yeah. And when a creator sees that they've created something very nice, that's your satisfaction. That's us going to the next project with maybe a little bit more confidence. Firstly in yourself and also in your teammates. And also when we have team events, we've gone in, out of our spare time, we've gone and done things together, and that's been pretty cool. So there's many ways, but for intellectuals, for creators, it's seeing your baby, firstly seeing it grow, and then seeing it develop into the full thing. That's very good motivation.
So you told about many key points, but the first thing that you mentioned was the clear structure. So if I understood it correctly, that clarity in who is doing what, clear roles and responsibilities, and this communication, daily cooperation with each other. So this kind of collaborative environment.
Yeah. And it's the feeling of genuinely being useful and genuinely being needed. Because unless someone fixes that mechanical jig in the way that the automation system requires it to function, nobody else is going to do this. Yeah, so you feel like you're in control, you're in charge. Yeah, so you can't let down your team. And then there's bonus points, obviously. Once you fix it, once it's running, it's like, hey, yes, we can continue. Yeah, so it's a great feeling.
And if we talk about leader versus manager. In your opinion, what do you think? Is there a difference between leader and manager?
Definitely, yes. There's the literal difference, and there's the characteristic difference. So literally, a leader doesn't need to manage. A leader can be a role model. A leader can be a teacher. But a manager is someone who's responsible for things running. They don't necessarily lead. You can have a very laid-back manager with superstar engineers, and all he's got to do is not stay in the way. You just let your engineers do what they do, and that's manager. But if you have a leader leading superstars, maybe that works well, but maybe it's a good option for the leader to realize that these guys are doing really well, so all I need to show is the path. You see this in sports teams sometimes when they buy all the best players and all the best managers, and somehow they can't click.
Do you think that it's essential that manager not just be the manager, but manager be leader? So one person is manager and leader.
Yeah, that's not an issue. I think that's what's happening with us right now. So my manager is his name's Francois. He's got about 30 years of worth of experience as an engineer, and he's managing our team right now as well. And it's fantastic how he keeps an eye on us. He lets us do our thing, but it's only when he feels that someone's in trouble or someone's struggling with something, and he actually shows up and proposes some ideas or just describes that, 10 years ago we did this kind of thing, maybe you can consider that. Or, and generally his wealth of experiences is very useful. And the key why he's a fantastic manager is that he knows when exactly to come and drop that little bit of leadership. That's what makes it a fantastic manager.
So if I understood correctly, that this good characteristic would be not to micromanage, but to like kind of surgical approach, in the sense that you give this freedom and then you come only when it's necessary.
In engineering, yes.
But not like kind of putting yourself over, like pressuring with this over control.
This applies in engineering. I've also worked in a restaurant where the vast majority of employees were teenagers, and roughly half of the time they showed up to work hungover, so they weren't able to perform very well. And in this case, if you let them do their thing, you're not going to have a very good restaurant. So that's where micromanagement is perhaps the better option. But if you have skilled engineers, experienced engineers, you can trust them. Just show them where we want to be, where's point B, and let them do their thing. Yeah.
If you talk about trust, are you for like proving yourself trustworthy or giving credit of trust to like maybe to empower?
Rather give credit. In my case, nothing really against proving, but your CV should show your proof. In a job interview, you should prove that you can do what you say you can do, and then you give credit.
And when you talk about this proof, when you hire, let's say, someone, and you have the CV, then there is this interview, then there is probation period. What do you think? This what should be the sufficient, if there is a need for probation period, and what should be the sufficient amount for probation?
I guess the probation period usually goes by the law, so how long the law requires the probation to be, and that should be sufficient. Luckily, in engineering, it doesn't take long at all to find out that you're not the person who you represented yourself to be. So the usual 4 months or 6 months, that's enough. But in other jobs, maybe even that's not enough, so you can't tell.
let's now talk about some kind of different scenarios, and maybe not the easy scenarios, which might
Sure.
be in the workplace. For instance, your manager gives incorrect data during the live presentation. You like listen, and there are lots of people there, and you hear, and you are also kind of responsible for this project which you're working, and you're responsible partially for this data, and you see that what your manager is presenting, this is clearly wrong. But it's live presentation, a lot of people listening, sitting over there. What will you do in this situation?
Do I sit next to him?
No, you don't sit next to him.
Okay. Because that would be a good option to just whisper or quickly write on a piece of paper to quickly describe what happened.
Okay.
Now it depends on the criticality of the mistake as well. Is it just a punctuation error? Did he say newtons instead of kilonewtons or something along those lines? So some things would be just a quick sanity check, so the viewer would understand that the units are obviously wrong if it's that big of a difference. But if it's a clear misrepresentation, saying that something's 80% efficient, but the manager stating it's 95% efficient, then that's a more difficult one, I think, because then it makes us look like we're showing a better picture than what it is. I'd be very surprised, first of all, and depends on the audience again, depends on the teammates. Am I the only one who can correct them? There would be, in some cases I would choose to whisper or just state in some way that, this doesn't quite look right, was it not 80? But at the same time, if my manager is stating something different, I would start questioning myself as well. Maybe I remember this incorrectly, maybe I don't know, so interrupting would not be the best option, or not the safest option from my perspective. But yes, immediately after the presentation, I would definitely let them know was really 95. Are we talking 80 or 95? Which one is it? And then immediately after, we should send a correction email to the audience. I think that's the most diplomatic way. But if the environment enables us, of course, piece of paper, just quickly whisper, what, 80, it's 80. So yeah, that would be my option.
See. Tell me how do you see the future with the AI, this machine learning, deep learning, that data science, and let's say in your field, in automation engineering?
AI as in performing tasks, or AI as in developing engineering devices?
As you feed this, like future trend in your area, how these basically tools, how they can be applied.
Okay, that's a fairly easy one because I have a PhD in this. So that's what used to be my bread and butter for 5 years. So currently we're talking about Industry 4.0. I'm not going to bore the audience with what that is. I think everyone's had a very good opportunity to learn about it, whoever's been interested. And who don't know, then it'll be difficult to describe in a couple of minutes. But if we're talking Industry 4.0, we're talking about mechatronics, but with feedback, with data feedback, and doing something useful with the feedback. So the whole concept revolves around self-something. I like to think of it as self-managing system. So it's a diagnosing system, self-maintaining system. It can be self-reconfiguring, self-organizing. There's a lot of some things that can be applied once a machine's clever enough and it gets information back from its environment so that it can perform its task better. That's really where technology is headed, and that's where AI comes into play.
Maybe some kind of specific example, or even from your times of PhD,
We've had a clever camera system. So you just have two cameras. Yeah. The one camera is looking at the full picture. It's a metallic surface. When it looks at it, it notices some kind of a deformation, something that shouldn't be there. Then it comes much closer, and with another camera inspects it from very close. So this way, the camera knows where to look, and is going to look exactly there with the highest possible resolution. And that's how we don't need to take lots of section pictures. We don't need to waste time on this. We're a little bit more clever. We go and do that. What my PhD project was about was large structure assembly. You can think of aircraft wing panels. Those have some very strict requirements, and we're talking about hundreds of thousands of holes in one panel. If you do that with one machine, your cycle time per panel will be very long. What you can do is you can add machines. Of course, there's technical challenges to that, but imagine if you could choose whether you have 3 machines working at this at the same time or 1. Or maybe you can somehow put 7 machines. Yeah? You go 7-fold in the manufacturing time. This enables you quite a lot in terms of flexibility, in terms of rush orders. So management might decide that, hey, we need to finish this aircraft quickly, we're falling behind, so let's prioritize this and send more resources there. And you can also do this with AI. So I set up a socio-economic system where every machine is an agent, and it's got its own communication module. It can communicate to products. And products are the customers who've got credits. They're not real money, they're not real credits or anything, but just virtual credits. And basically the products that are more rushed, that are risking being late, they increase in purchasing power. And through communication, there's a self-organization of machines happening, so that we reach an optimal solution in terms of when the products are completed. And this happens completely independently of people. Nobody has to take anything into account. It's just machines doing their thing.
So it's basically efficient use of the resources, available resources.
Yes.
And like smart prioritization in a sense.
Yeah. And
well, this is really cool. What you worked on.
It's fascinating how much science and robots and in general AI feels unnatural, but how much that actually takes inspiration from nature.
Exactly.
Yeah.
I think people who are implementing and deep into this AI topic, they actually study neurophysiology and everything related to how brain works.
Yeah.
I definitely agree with you on that. And but what was your? Do you know if it was implemented with, I don't know, was Boeing or Airbus?
That would be an Airbus project. It has not been implemented yet because of technical difficulties that have to be overcome. The point of the PhD project was to show that if you build this technical capability, this is the sort of benefit you can get.
Did you go to the Airbus factory and try out this?
No, that's not. No. Because we needed mobile robots for that, and currently it's done with static robots. The purpose was to have, instead of moving products to machines, we move machines to products. Yeah, that's a very completely different concept, and this is specifically good in industries where your products or your components are enormous. That's why the project applies to large structure assembly. If your product is huge, you'd rather not move it. So that was a case for mobile robots. And there were pretty many questions. Yeah. I really appreciate your patience in answering all those questions. And the final question in our job interview is, what's your salary expectation? You know what? I'm very happy with my current salary. But if I were to change, let's go 30% higher than what I have right now. Yeah, then that's enough to motivate me to move.
All right, noted.
Yeah.
So here we're finishing this job interview.
Thank you very much.
We're switching from the job interview mode. And so how do you feel? Is it like was very tough and challenging?
It was an intellectual discussion. I'm surprised I wasn't asked about how I'd be going about the ergonomics of the shovel or the Swiss Army shovel, yeah, and all of these things. So I thought I'll need to quickly think of some plan how I'm going to build one of these and how I'm going to divide the labor among the engineering teams and all of this. But there was a bit more philosophy involved than I expected. And philosophy is quite a strong side of mine, so and I feel comfortable there.
Well, you are, if you say PhD, doctor of philosophy.
Yep, exactly.
Well, not doctor in the medicine, so.
Yes, it's a funny thing. There was this one time I did some extreme sports and I got severely injured, and I went to the hospital. And there was a doctor, and she didn't really feel much sympathy for me. She said, yeah, so every summer you guys do some crazy things, and then you get really hurt, and you expect me to heal you, yeah? And my answer to that was probably my favorite answer in my life so far. I said, you may laugh at me, but I'm also a doctor.
I know the cases. I saw there are some memes in the internet. You can find that. Who is the doctor here? I'm the doctor. Can you help the person who fell down?
Have you tried switching him on and off again? Or the other way, actually, off and on again.
Great, and you have extensive experience. You've been in different areas, in different fields, and have different job interests. How's this one is like different or similar to other ones?
Usually it's not as much of a discussion format as much as it's ticking boxes. So the people hiring, they want to know if I can do the things. Firstly, am I a likable person? Can I fit the team? Yeah, maybe I'm a fantastic engineer, but I have a terrible attitude. Not many want that. And then the technical abilities. Are you familiar with Siemens PLCs? Have you programmed BNR PLCs? Have you worked with ABB robots and all of these? And what have you done? What's the most complex project you've ever been in? And did you do it on your own? What is the division of work in there and all of these things? So it gets very technical, very detailed, because most likely the people hiring, they have some projects either ongoing or they're planning some projects to start very soon, and they're looking to find the correct person for the position. Which is why I was surprised there's not much shovel talking in here.
Well, indeed, you're absolutely right. But here we were talking about leadership position, and of course, knowing that you are doctor of science, so in the intelligent automation, so quite experienced. So here it's probably more indeed focused on people, on working with people in engineering setup, so to say. And at least from my personal experience, that's what I experienced. That I was like preparing a lot of technical stuff, reading, and I come and people said, "No, we're interested about how you people side."
It can happen, and it's important not to steer away from what the person's asking, because it's not as much as answer everything correctly and get 100 points for answering. It's also a lot about not being the annoying guy who's going to show up and say, "Hey, you're not going to ask me anything technical. What's wrong with you?" Yeah. So you also need to be that likable person and go with the flow. Exactly.
I would say a lot from this nonverbal communication, like how you answer and especially those cases. When I personally was hiring, I mixed, and I was having some kind of scenario tough question, like with this, for example, how you would do with the manager. And it was not so much about what you answer. It was more about how you handle the stress.
Yeah.
Because
absolutely.
I saw quite many people were getting into stress they're just getting lost and cannot answer anything.
Yes, and the candidates that didn't get offers from me were the candidates who didn't have the ability to say, I don't know, I'm not sure, I would need to figure it out or something. Instead, they thought that, okay, this is my moment, I have to answer something now. Yeah, just say something, put something there. Yeah, like in an exam, you either get no points, you can't go back and try to figure out what the solution is. In an exam, you just, maybe if I write something at all, I'll get 1 point out of 3 in this, for this answer, yeah? So I saw a similar kind of attitude from some people in interviews.
And you highlighted actually very good example, very good point that it's human, it's okay to say, I don't know, or I don't know, to show some kind of a bit of insecurity.
Yeah, I think socially, the general average person might think that an engineer is a walking library or something. But in reality, an engineer is someone who can find something out, someone who has a good basis, but doesn't do exactly the same job every day, does new things, and that's when you find out things, when you know how to figure this out, that's how you get your solution. But, someone who's a full-time baker, maybe they think that an engineer automatically has an answer and just builds whatever they build, and that might not be the correct assumption.
Yeah. And a lot of people will be watching, listening, and potentially applying, using some useful information, some knowledge to prepare for the interviews when they go. But not only in this setup, I don't know what could be different scenarios, but what advice would you give to engineers who want to become leaders?
I would say practice the what I'm calling the zoom in, zoom out methodology. So you zoom in into fine detail, but also take your time to back off and look at the big picture. Yeah. Because if you want to lead engineers in the long perspective, you need to understand what's cooking in their kitchen. At the same time, you need to fit this into the big picture. So as long as you have the big picture in control, under your control, it's all great. So don't think that leading engineers is just about one automated screwdriver or something that's tuned to perfection. Think about, does it even make sense to automate the screwdriver and to optimize it, because maybe the cycle time is already very good and you have bottlenecks elsewhere, or maybe it's the optimization is just definitely not worth the money. If you get 1/10 of a second off of the cycle time, and for a high price, then it's not great, despite it being a great engineering achievement, of course. Yeah. So leading is also showing what makes sense, what doesn't make sense, and that's what you get from just backing off and trying to fit big pieces into the big picture.
Thank you.
Yeah, no worries.
That was Spartak Ljasenko in the episode of Leaders and Engineers. Thank you for watching and listening us.
It's been a pleasure.